Welcome to a discussion this morning with Nathaniel Nance of American Air Filter. And Nathaniel, you've got a pretty impressive background here, but I'd like to have you, if you would, kind of walk us through. I think I didn't do justice here to an interim position you had just up until recently, again, with relative to the product analysis and things too. But explain some of your more recent history and your background, if you would.
So basically, I've spent outside of being a teacher by trade, I've spent my professional career in filtration, working for media companies, primarily Alstrom, and then moving with AAF to build filters. I've worked on really all sides of filtration, from industrial, gas turbine, being a plant manager and doing some development work on that side, air pollution control, and then primarily most of my work has been, managing and delivering new products and product enhancements for the HVAC, clean air type environment. So that's what I've spent the last 4 or 5 years managing, basically director of global research and development, and then recently promoted to vice president of global R&D for the HVAC division, which is kind of all encompassing, with a little outside. We have more focus now on a different division that really focuses on high purity in some of the equipment.
And then with your acquisition of Flanders a few years ago, that broadened some of your HVAC type activities, did it not?
Yeah, so we've primarily over the years, American Air Filter, being almost 100 years old, has done pretty much everything. But where I would say the two companies differ in the acquisition and where they fit so well together is AAF was primarily a direct and distributor channel where we focused on commercial industrial, and Flanders had kind of two sides of the spectrum. They had retail production filters for in your home, standard commercial filters, and then their big focus, and historically where they've always been number one in the industry, is your bag in, bag out, high end, high purity containment type production. So starting in Flanders, New York in the 60s, they really led that charge, to where if you go into a critical environment today that's been around for a while, you're going to have some Flanders bag in, bag out housing protecting any critical space that really needs the highest level of filtration. For example, it's real nice to know that right near our corporate office, the University of Louisville has a BLA 3, biological lab safety level 3. About 2 blocks from our corporate office, our Flanders bag in, bag out housings protect the city from that, any potential there with systems upon backup systems upon backup systems. So we have this real nice mesh between the two companies of encompassing everything from start to finish in the world of air filtration.
Yeah, that really is a nice is a nice fit. We've been around long enough that we were tracking Flanders as well as AAF over the years, and the thing that impresses me about AAF is that I've known about AAF for many decades, and AAF has been a leader in HVAC to a degree possibly that a lot of people don't appreciate, because back in the 40s and 50s, and even if you want to go back to the 30s and things like that, AAF was taking a really dominant position in the field all the way around. I mean, when it came into, not only in the filters that were used industrial for HVAC, but even things like, take Cupelo cyclones. Every Cupelo in the country had a high efficiency cyclone from AAF to keep the dust from ruining the cars in the parking lot. So, and that brings me to the next point, that because what I'm moving on to is some of your comments in International Filtration News. And I think what you're really saying is the industry is currently disjointed between filtration experts, universities, and HVAC and so forth. And the future will evolve from these groups coming together. But my contention is that time has passed when we should be letting the epidemiologists guide things, just the way the air pollution researchers were not guiding the activities of the purchasers and AAF when it came to things like cupola dust collection. Now it's time for suppliers like AAF to step up and guide the epidemiologists rather than be subject to whatever their thinking is. And so I'd like your comments on that, because that's what you were really addressing in a tangential way here.
Yeah, and I think it also is to be transparent about a little from a safety standpoint of, I think by not engaging air filtration specialists early enough during this crisis, you're at a disadvantage. You heard Kumo the other day state that we're going to want HEPA air filtration in malls. Well, no HVAC manufacturer is going to recommend that, because you're not a sealed building. You're not, this would be a challenge for the industry to solve quickly, or even have the capacity to address issues like that. So I think it's coming down to, we as filter experts can tell you what we can take out. If the viral experts can tell us what we need to take out related specifically to this, what we primarily hang our hat on is, all right, experience tells us this is how you remove viruses. Here's your risk on virus carriers. And these are the filtration mechanisms that we recommend, and filtration solutions to do that. But without combining your government regulations, your viral experts, your HVAC companies, and your filtration experts, there's a lot of gaps right now on what people should do, when they should do it, what's the best solution. And so it's really left up kind of as a modge podge of things for people to come together on their own. And I see that happening, that we're getting more, we have the advantage of being owned by the largest air conditioning manufacturer in the world. So we are having weekly meetings on, these are things that we need to do system-wide going forward to make these solutions viable. Because if you look at the old school HVAC development, they're putting something on your rooftop. They're wanting to throw a fiberglass filter in there to protect the unit and deliver as much cool or hot air as possible. And that's really what their focus is. Well, now we've changed the game and said, well, filter companies have been talking about clean air, but how do you really, deliver that? And I think we've progressed through the years on, hospitals and minimum requirements, and California has really led the way on some regulation to really give the consumer knowledge. I think the big challenge that is always faced is, a clean glass of air and a dirty glass of air looks the same. And most people don't realize you have a choice on what you breathe if you make the right decisions. And so I look at my job and what AAF does, AAF Flanders does, as we're the global resource to assist people, help people make the correct decision for their environment and their application. And in this time of coronavirus, here's where we can lend some of our expertise to really assist people when possible, solving problems, delivering cleaner air, but then also having the knowledge to say, okay, your system is this, your setup is this, okay, that this may not provide the results you want, here is also an adequate solution for the system you have, as opposed to, I don't think blanket statements work in this environment.
Yeah, now you mentioned Daikin, of course, and being the largest air conditioning company in the world, and you're part of that group. And you've got a situation in the South now. You're seeing Texas, Phoenix, all these places, this huge spike in virus outbreaks, and you've got situations in Phoenix where the recommendation to bring in outside air to dilute the virus is completely impossible because of the air conditioning loads and so forth. So it really takes a solution that has to take into account something that's not quite as simple as, oh, well, we just shut off the air conditioning and blow clean air through the building. So I assume that you people are addressing the challenge of that's presented by these cities like Phoenix.
Yeah, it's a lot of discussions with individual units, whether that be a hospital or university, and how do you filter the air yet keep a level of comfort? Because everybody, I think, would be in agreement. Why have an HVAC system if you're going to be hot and miserable all the time? So, or cold and miserable. So it's a very interesting dynamic going on with that, of as you have these different systems, each one is requiring a little bit different solution, because it's not an end all be all. Yes, we do support the recommendations of increasing outdoor air because it's clean, or it's almost clean from the virus, versus indoor air, which you don't know. So we do support that, but along with that, you got to have filtration in there, in particular barrier filtration, that will prevent items from getting downstream and continue to make the situation worse.
And that's where really the skill of because when it comes to filters, you've got obviously pressure drop that's a function of velocity, and the larger you can make your filter, the smaller the pressure drop. But in existing buildings, that may not be all that easy. Is that correct?
Correct. And I think it's also letting the consumer understand. And I think for the first time, the fortunate thing AAF has, or AAF Flanders has, I apologize, I go back and forth depending on the country we're in, is that we have this really at 100 years, a couple lifetimes of experience in this. So there are solutions out there really for every application. But I think now people are willing to listen, that they are less concerned about the financial impact of spending a few dollars more on a higher level filtration to actually coming up with a solution. And that's really been a nice change for me as someone that can go home and say, what did you do today? Well, I tried to help people. And this is actually a situation where we are doing our best to help people in these situations and try to expand the overall picture of what people look at as clean air and how do you do that.
Yeah, and I think that a lot of your comments in this International Filtration newsletter are certainly very interesting. And the technology integration, you might want to talk about that for just a second here too, with fans, humidity, UV, recirculation filters, and so forth, and even the biosensors. Yeah.
Yeah. So basically, technology helps you see that air. Like I had said earlier, you can't tell the difference between a glass of clean air or a glass of dirty air. And so not being able to see that, we need technology to come to the point where it can tell us what's there. So from understanding rudimentarily what the filtration level is of a system with different airflows and different filters, now we can actually monitor it. AAF Flanders has came out with a few sensor programs. I know there have been others out there, but how do we move that ball forward where now you're looking at, can you get to the point where you're monitoring the levels of virus in the air in real time? And then that allows you to do something about it. Because if you can't monitor it, you can't act on it. You can't respond if you don't know what's going on.
And
And go ahead.
I was going to say, at the very least, to be able to correlate particulate loads, and even if you can't measure the virus loads in real time, you can be measuring them uh, continually in in samplers and correlating it with particulate loads. Can you not?
Yes, and really you've got a situation where when I speak of technology, I'm not just talking about the next cool sensor or electronic gadget or the eye filter 12. I'm talking about really going into the technology from the standpoint of understanding what you're seeing downstream or upstream, and then what are the algorithms and programs that are going to come out that are going to allow you to predict what you need to do. If your airflow is 100 CFM through a system, well, you get pretty good filtration increases just on that low CFM level. What is it that you need in that situation between something that is being overran and overcapacity of the system, and understanding what those are outside of just pressure drop and just what is the filtration level of the filter, what is the design metrics that are going to have to go into, and the software support and the sales technical support that needs to happen almost automatically within these systems to really start performing at a level that is an improvement over today.
Yeah, I think those are all some good points there. Right now, there's a big concern over the schools opening, and you mentioned New York a few minutes ago. Would you want to comment on the what needs to be done and what can be done for a city like New York City that's trying to reopen its schools now?
Well, I think it starts with the standard recommendations of, filtration is a great resource to have, is a great support structure and engineering control to help once the air hits the HVAC system. What we can do to it is pretty well known. I think for these school systems that are looking at it, they have to balance what their system can handle with the filtration level that, really maximizing out that filtration level. But ultimately, like in any, whether it be pharmaceutical or clean room or hospital, your biggest contributor to particles, no matter what type those are the people walking in the door. So you have to, do those, recommendations of social distancing, face masks to prevent that direct contact. Outside of that, the standard recommendations of improving your filtration to remove as much as possible is always good and where we can help. But, it's one of those difficult challenges where we could have the best HEPA filtration in a school possible, but if you've got students sitting 2 feet away from each other, talking to each other, you can't stop that. So that's where the limitations of filtration exist, is once it's able to access the filter, then we can get really good results. When it's not, it's one of those things of, like I put in my article, it's the coming together of everybody. All right, if you do all the right things on a personal level to minimize, filtration is a great support structure in engineering control. If you do not do anything from a personal level, filtration is not going to help you a significant amount.
Yeah, that's a very good point. But if you're going to be replacing filters, it's critical what kind of pressure drop and efficiency that you get. And so we've been writing about your membrane filters and things here. I think maybe I clicked on the right. Yeah, here is this these most penetrating particle size of the micro fiberglass versus membrane. So I'd like to get your comments on to what extent the membrane ULPA media can be a contributor here.
But the the biggest advantage you have with membrane filtration as it relates to what AAF Flanders produces is pressure drop and strength. So pressure drop from the standpoint of now you can put higher level filtration products in applications that would not warrant it or could not handle it before. So when you're looking at 50 to 60% reduction in pressure drop at high level filtration, this allows you to put a much better filtration. And because of the mechanisms of membranes utilizing surface tension and basically nanofiber nodes within the membrane, you're able to get, like you see on the curve here, a much higher level efficiency, even though the MPPS efficiency is still where it is rated. You can see that if you looked at those curves and you filled those curves up with water, the microglass curve would hold a lot more water, which lets you know that there's a lot more particles going through for the same level of filtration. So you basically upgrade your filtration even at the same level for less pressure drop. And the secondary benefit of membrane filtration is the strength of it. I always use the example, you've seen pictures of myself. I'm not a small individual, but when I can stand on a filter and then put it in a test duct and get the same results that you would expect before I stand on it, I think that's eye-opening for people to see, okay, that's the level of strength difference we're talking about versus a microglass, which you're going to struggle at times with strength. Microglass definitely has a place, but when you deal with critical environments where you can't have breakage, when you can't have some of the areas of filtration in PPS, the membrane is really a revolutionary idea.
Yeah, so that certainly, and I think one of the things we're saying here is that there is new and better technology in all these areas, and even more to be developed. So we have to be taking advantage of it. And it would seem to me this is definitely one of the areas that where you people are making advances there. I wanted to just move on to some of the concepts of HVAC. First of all, in meat packing plants like this, where they're just putting in partitions, I think all that's going to do is to, well, in fact, we have another view of that down here further here. I guess I thought I did anyway. I guess we don't. Where all that does is create turbulence. And so I was just interested in your comments on what the meat processing company should be doing.
This would be a prime example where you would want to be, if I was saying I'm going to send my kids to work in meat processing plant, you would definitely like maybe some FFUs above these individuals, pushing HEPA level down. If you think of a LED TV manufacturing facility where you're actually putting these separate filter fan units above this staff to not only create solution by dilution, but you're also providing HEPA air. So you're limiting the exposure. I think one of the unknowns that we look to the viral experts on is what is the viral load someone has to be exposed to acquire this new disease. And as you can see here on this, if you imagine on your picture here where you've got the 1, 2, 3, where you're dealing with these FFUs that are filtering the air really at the application spot. So wherever someone's working, this is going to be able to provide, clean air to them and the force down. So if we can keep the virus at a low level and we can keep clean air in the workspace, then you have a lot lower risk of any contaminant getting into someone's airways.
Yeah, and so it would seem to me, just as you're saying, this is a fan filter unit, and there are a lot of these now being put into retail stores in Austria, and it seems like this is a big step forward. And for the meat processors, this is the kind of thing they really need, rather than the partitions that are just going to create uh, all sorts of turbulence and maybe even keep. For instance, in Wuhan, they found that there were a huge deposition of viral particles under some beds, and they figured out it was the air turbulence through the area that was creating these little cyclones under the beds, and that's why you had that concentration of a deposition. So certainly the flow is critical, right?
Yeah, and you want to make sure, even from diffusers to FFUs, that you're getting the most um, basically streamline HEPA air to the individual, or the cleanest air possible. It's the standard. We have diffusers up in most places, and HVAC systems are designed to not impact an employee. Most people do not handle having cold or hot air blown on them nonstop. And that's primarily from the standpoint of, if you're looking at pure physical comfort, that's great. But now when you move to safety, and you look, I look at it this way, that over 100 years, a lot of engineers have came up with very intelligent, novel designs, and you look throughout industries on how you prevent this. And if you look at, and unfortunately, our environment typically protects equipment, processes, and agriculture more so than humans. But if you look to those areas as a guide, all your microelectronics, all your pharmaceutical, they're having direct airflow and cleaning of that air right at the application spot. So you're not having any risk, or you're minimizing as much risk as possible at that interval, as opposed to something 500 feet away. Because as everybody knows, if you have a system that's giving you HEPA air 100 meters away, there's no way that air is HEPA by the time it gets to you. So the closer to the impact of personal space, the better the system will be.
Yeah, I think that's well said. I was struck by your comment that you want citywide filtration solutions. So I was just curious in what you think of this modular filter cube, which they're putting in traffic intersections, traffic junctions, as you can see here, and all sorts of different places where you're actually cleaning up the ambient air in an area which is unusual.
Yeah, I think what we're seeing is that small particles and air pollution, once again, that not knowing what dirty air looks like, now we're starting to see what dirty air looks like, and we don't like what it looks like. And so having systems, and let's even go as far as saying smart cities, that understand that if you've ever flown into Shanghai on the middle of a warm summer day, you can't see the city till you land. Those particles are not good for humans to consume. And so any type of systems, and there's lots of research products out there, research projects out there through universities that are looking at large level filtration for cities. Mostly the primary focus has been on pollutants and chemical contamination, but at the same time, now that you're talking viruses, now you're talking more of how would you design your city if you knew that this virus, the next big one, is going to be terrible, it's going to be airborne, all the things that worry people. You would design systems you would design your city to basically have a very crosswind direction. You may even create fans, you may create airflow patterns throughout your city to try to process as much air out. There's not going to be one filter that's going to solve an entire city problem, but you can do things with city design and how you shape the air through your city, that you're going to get that solution by dilution of, yes, 10 ppb is really bad, but 2 ppb is acceptable.
Yeah.
So trying to minimize that sheerly with design, which way the wind blows. Are we going to put giant louvers to direct air through a city? So we're, in essence, having Mother Nature clean part of the air, and then worrying about some of the other items that could be there. And it may be filter banks outside the city that are trying to purify the air before it comes into the city. There's a million ways you can go with this, but I think that in general, people are going to start saying, hey, you know what? We have these huge water filtration plants that I saw probably the best presentation by, I'm trying to think of the company's name, about water filtration, about, here's the cost for clean water. Here's what our expectation is. Here are the systems we put in place to reprocess this. We don't do anything for our air in our cities today. So if we realize that water can hurt you, and now we're realizing air can hurt you, what are the systems like a sewage treatment plant that now becomes part of a cityscape that when you do design, if you really want clean air, if you really want something for the future, this is what you can do? Because there's a lot of impoverished areas in third world countries that just simple designs for low impact cost, really, you could create a situation where people are being exposed to significant reductions in what they are today.
And I think we're finding that well, certainly you alluded to the levels of pollution in Shanghai, but of course now in places like India, it's even worse, and you're getting relatively high death rates. One other thing that is going to lend itself to some of the strategies that you are enumerating here is more sophisticated monitoring. I believe it was St. Louis that installed multi-metal analyzers, and as you know, the toxic metals pollutant reduction has not been we've not been able to measure the individual metals, so we're using particulate as a surrogate. And even though St. Louis was easily meeting its particulate levels, it turns out that when the wind is blowing from the south, the lead content of that particulate load is very high. So from a toxic metal standpoint, they were exceeding what you'd want to have considerably when the wind is coming from the south. And from what you're saying here, if you've got this more global strategy, you can have dilution factors possibly that are a function of where the wind is blowing from.
Absolutely. And you can start looking at what, simple things like that of we have, we're getting significant airflow over a river. Is there a way to simply louver that and push that? Everybody's walked on a riverfront and felt the breeze. Is there any way to get that 3 blocks in? If that gets 3 blocks in, what does that do for the health of the patrons in a city? I think there's lots and lots of, we like to focus on indoor because that's where people are, but I think there's a whole filtration solution here in combination with, what plants do the best at filtering products out. And you start to plan from a city perspective, and city planning goes to, we need to have a park here, we need to have, this is where we need to build, the major part of the city at the bend in the river, so you're able to strip some of the wind off and dilute the air, reduce the pollution levels, and then you have less to deal with inside and out.
Yeah, I think those are some. I had never thought in terms of using airflow in the cities, but yeah, if you think about it, this is the dilution that we're applying elsewhere can be applied on this more macro basis. So I think it's a very good point. Finally, I'd like to move on and just get some feel from you as to how all these different filter options can be utilized in various different ways. And I turned to your green building brochure, and you might just want to comment on all of the 3 options at the different levels of efficiency here.
Yeah, basically what we try to do is give a customer insight to a good, better, best. I think that's really what we've found, that people like options. As much as I want, as a scientist and a filtration expert, to say you need to use this, a lot of people don't like that approach. They like to break it down into um, cost conscious filtration solutions. And when we talk about the best, we're talking about, the highest efficiency, lowest pressure drop. And then as you move across the better, you still maintain the efficiency, but you may have some pressure drop concessions, some life concessions. And then the good meets all the requirements to give you clean air. It just is not at the energy savings and potentially the life that some of the others are. So we give options like this because a lot of times people bulk on the overall cost of a filter, especially when you get into these high efficiency filters. They have high tech media. It's very lots of components. There's lots of it. And so when you combine everything, it does give you the good, better, best. And we try to track that with, this is really, if you look at just a straight multiplier of cost, they fall in these groups based on those two factors. You try to get the best value, and we try to promote that the most, but at the same time, any one of these products will deliver what the customer is looking for. We're just trying to give the best solution.
And then one last question would be relative to the gas phase removal. Are you accompanying these primarily with activated carbon type gas phase filters, or what's the option on the gas phase?
So we do it all. We do activated carbon. We do potassium permanganate. We have the whole breadth of gas phase removal, and we do it the same. Or I personally think a little better, but in general the same, looking at the gases you wish to remove and then pairing that with the best product to remove that.
In one of your comments in that article there, you did mention the charging. Was that for the micro glass type of electrostatic charging, or were you thinking of a more positive electrostatic charging? Of course, obviously you make electrostatic filters, precipitators yourselves.
I'm talking about charged synthetic medias and electric precipitators as well. Really understanding what that means to the consumer is, I think, where we need to go. I think everybody offers product lines that we try to be, give the whole branch of this. If a consumer can only handle a certain pressure drop but would like the most efficient, that's where charge comes into play. But if you have an option to get a higher level filtration in a mechanical type form, that's better. And I think the agreement on that and how to rate that, I think, has been a large discussion point for many, many years. And trying to get that aligned is a big priority during this time.
And then one last point on that, the ionizers talk about killing or inactivating the virus and their various different coatings and things. How effective do you think efforts to inactivate the virus as opposed to just capture it are?
I will respond by, we don't sell that.
Okay. Yeah, it's to be determined, I think, out there. Well, Nathaniel, go ahead.
The issue we have with filtration is, with barrier filtration, we know or almost know what the performance is going to be. When you take the barrier out, then you automatically have risk. And I do not know, and I think no one can really predict what all the factors that could affect the performance of a non-barrier filtration level is. So it's better than nothing, and it may be much better than nothing, but a barrier filter allows you to really understand your environment, predict your environment, whereas alternate methods have factors that all come into play that you just like catalysts, depend on humidity. There's lots of factors that you have to take into consideration with those. Currently, we don't do that.
Right. And of course, as you point out, the barrier filtration is a positive way to to remove them. Well, Nathaniel, it's been great to get your comments here. I hope we can do this again. Things are changing so rapidly that I'm sure there'll be a lot of interesting things to talk about in the future. So I'd like to thank you very much. We'll put this all up on YouTube and people will get a chance to hear you. So thanks again.
All right. Have a great day.
You too. Right. Bye now.